Yes, my name is Lakshmi Narayana. My channel name is LN Brand of Chemistry. So today we are discussing about the chemical equilibrium. Chemical equilibrium. Before going to chemical equilibrium, first we have to discuss about two different types of reactions based on the direction, such as reversible and irreversible reactions. So first, if we discuss about the irreversible reaction. Irreversible reaction. So what are the irreversible reactions? So what are the irreversible reactions? For example, a reactant can be converted into a product. So here 100 molecules of reactant if you take, then 100 molecules are going to converted into product. That means almost all the reactants can be converted into a product. Such type of reactions we are calling irreversible reactions. Are you getting my point? So irreversible reactions nothing but the reaction almost complete and the reactants almost consumed. Such type of reactions we are calling irreversible reactions. So irreversible reactions are how many types? So that we have to discuss. So irreversible reactions, different types are there. Nothing but, sir, the reactions which completely converted into products. Such type of reactions we are calling. Such type of reactions are called. Such type of reactions are called irreversible reactions. Irreversible reactions. So what are those irreversible reactions? What are those irreversible reactions? For example, if you take decomposition reactions. Decomposition reactions are maximum irreversible reactions. For example, KClO3, potassium chlorate, can be converted into or heating. So this symbol indicates the heating. Thermal decomposition takes place. Then 2KCl plus 3O2. So that is a decomposition reaction. All these decomposition reactions, reactants completely converted into products. Such type of reactions only we are calling irreversible reactions. Then second example, if you take this, so CaCO3 in the open vessel, that will be converted into CaO plus CO2. Even such type of reactions we are calling irreversible reactions. So one more example I will give, that is water is present in open vessel, H2O in open vessel, H2O in open vessel. Even such type of reactions also irreversible reactions. Then one more, reactions between strong acid and strong base reactions. The reactions in between the strong acid and strong base are also irreversible reactions. For example, if you take HCl plus NaOH, then gives rise to NaCl plus H2O will be formed. When such type of reactions are irreversible reactions. Then one more, all precipitated reactions. All precipitated reactions are irreversible reactions. All precipitated reactions are irreversible reactions. For example, BaCl2. BaCl2 when reacts with H2SO4. BaCl2 when reacts with H2SO4. So we can get BaSO4. BaSO4. So it is a PPT. Then plus 2 moles of HCl. So such type of reactions also irreversible reactions. So irreversible reactions nothing but reactants completely consumed. Reactants completely consumed. Nothing but 100% that will be converted to products. Such type of reactions we are calling irreversible reactions. So note it. Second one, reversible reactions. So what are the reversible reactions? That we have to discuss. Reversible reactions. So here, before going to the reversible reaction, one thing you can say about the irreversible reaction. Irreversible reactions are irreversible reactions are unidirectional reactions. Nothing but so only one direction from the reactant side to product side, only one direction reaction takes place. So such type of reactions are irreversible. Now second type we are taking, that is reversible reactions. Reversible reactions. So which are the reversible reactions that we have to discuss? So these are bidirectional reactions. So in between the reactants and products, we can represent with two arrow marks like this. Nothing but, so reactant can be converted to product, then product can be converted to reactant. So the reactions in which both forward and backward reactions are takes place. Forward and backward reactions are takes place. Both forward and backward reactions are takes place. Such type of reactions are called reversible reactions. So what are the examples for the reversible reactions? So now irreversible reactions, many of the examples we are seeing. So what are the reversible reactions? Which type of reactions are reversible? So first, if you take water if you take in the closed vessel. So first reaction, first example for this. First example, water present in closed vessel. So water, when it is present in the closed vessel, in the liquid state. So what happens when it is present in the liquid state? So here first vaporization takes place. So how vaporization takes place? So when it is present in the container like this, in a closed vessel, the water is there in this. Now up to here water is there, just assume it. So now these particles are converted into vapor when taking atmosphere, when absorbing temperature from the atmosphere. When absorbing temperature from the atmosphere, so these liquid particles are converted into vapor particles. So H2O can be converted into vapor. H2O vapor, same chemical composition, H2O only. But just a physical state will be changed from the liquid state to vapor state. Nothing, vapor state nothing but what? Gaseous state. So then after some time, so when the number of particles are increases here, when the number of particles are increases, they are colliding with each other. Then again, they are converted into liquids. When they are colliding with each other, condensation takes place. They are come back to liquids like this. So gases again they are converted into liquids. So liquids can be converted into gases. Gases can be converted into liquids. So two reactions, forward and backward reaction takes place. The reactions in which forward and backward reactions are takes place, such type of reactions we are calling reversible reactions. So vaporization of a liquid, it is one of the reversible reactions. So now one more example I will give to the reversible reaction. So that is, all gaseous reactions, remember it, all gaseous reactions in closed vessel, all gaseous reactions in closed vessel. Some of the reactions I will explain to you. So N2 plus O2 is lies to 2NO. Sir, all are gases. This is the gas, this is the gas, this is the gas. Sir, H2 plus I2 so gives rise to 2HI. 2HI. So this is the gas, this is the gas, even this is also gas. So all these reactions, even many of the reactions, we can say that when it is present in the closed vessel, they are converted into products. Then products can be converted into reactants. So both will happen. So that type of reactions are reversible reactions. So some more reactions I will explain to you, which are the reversible. Yes, just look at. So here, so one more example, that is CaCO3. CaCO3, solid only. This is a solid. When it is present in the closed vessel, so first CaCO3 can be converted into CaO plus CO2. So when it is present in the closed vessel, sir, CaO, it is a solid. CaO can absorb the CO2. Then can convert it into CaCO3 again. So both forward reaction and backward reactions are takes place. Such type of reactions we are calling reversible reactions. So one more example I can say that N2 plus 3H2, it is one of the famous reaction. N2 plus 3H2 gives rise to 2NH3. Which reaction it is that? Haber's process. Haber's reaction, preparation of ammonia. This is also reversible reaction. So all are gaseous reactions. When it is present in the closed vessel, all the gaseous reactions. When it is present in the closed vessel, all the gaseous reactions. So not only this, so esterification reaction. For example, CH3COOH when reacts with C2H5OH. So acid, carboxylic acid can be converted to alcohol. Then it will be converted to CH3COO C2H5. Ester is formed. So this is also reversible reaction. Ester formation reactions are reversible reactions. Then weak acid and weak base, ionization reactions. ionization reactions are ionization reactions are ionization reactions are reversible reactions. Reversible reactions. So these all are reversible reactions. Now we have an idea what are the reversible reactions, what are the irreversible reactions. Now we have to discuss about the equilibrium state. So what is the equilibrium state? So actual content is from the here onwards it will be start. So first just discuss the introduction. Two types of reactions, irreversible and reversible reactions. Now we have to discuss about the equilibrium state. So what is the equilibrium state? That we have to discuss. Equilibrium state. Sir, equilibrium state is applicable for only reversible process, reversible reactions, not for irreversible reactions. So note that. Equilibrium is applicable for only reversible reactions. Only reversible reactions. So equilibrium is applicable for only reversible reactions. Sir, how equilibrium state is formed? How equilibrium state is formed? So now one of the example first I will take. Now only we are discussed about the H2O, that is the liquid state is there. Then that will be converted into H2O in vapor state is there. That we are discussing. So vapor state nothing but here a gaseous state. So just assume this. This is one of the closed container. Now we are discussing this. So up to here water is there. What is there? Water is there. Water is present at this. Now, so when temperature is absorbed from the surroundings or atmosphere, now these liquid particles can be converted into vapor particles. Liquid particles can be converted into vapor particles. Now number of vapor particles takes place. So what happening there? So liquid can be converted into vapor. So now vaporization is taking place. What is taking place? Vaporization is taking place. Vaporization. Then again these vapor particles are, when it is increased in the space, then they are collided with each other. Then again they are converted into a liquid. That we are calling condensation process. Condensation process. So two reactions are happening there. So one is the rate of forward, one is a forward reaction. So one is a backward reaction. Both are taking place. So forward reaction is vaporization. Then backward reaction is condensation. So both reactions are simultaneously takes place. Both reactions are simultaneously takes place. Both reactions are happening. So here rate of forward reaction. Rate of forward reaction. Rate of forward reaction equals to rate of backward reaction. Rate of backward reaction, rate of backward reaction. So look at, sir, at this place, sir, liquid is converted to vapor, vapor is converted to liquid. So now both are simultaneously takes place. Equilibrium state nothing but both rates, rate of vaporization and rate of condensation, both rates are equal. Such type of reactions we are calling equilibrium state. Such state is called as equilibrium state, we call. Understand all of you? So that is the equilibrium state. So here one thing you can say that at equilibrium state, the concentration or mass both are same for the reactants and products. Concentration and mass both are constant for the equilibrium reactions. Constant. That you have to remember. So equilibrium state nothing but the rate of forward direction and rate of backward reaction. So both are simultaneously takes place. Such type of reactions we are calling equilibrium state. Then, so here we can say that equilibrium state, so concentrations are constant. At a particular stage, so in case if you take one of the reaction, A can be converted into B. So just assume it at a time t equals to 0, A particles are 100 particles are there. So B particles are 0, nothing is there. So after some time, so some of the particles can be converted into B particles. So product is formed. So now, so here just assume it 50 particles are there. So the remaining particles are converted to B. So the remaining 50 particles are there. So A can be converted to B. Then the remaining particles, in case the forward reaction takes place, B can be 1. So more than that, again it will be formed like this. So both forward and backward reactions are takes place at equilibrium state. So remember that at equilibrium, concentration of reactant and product, concentration of reactant and product constant. Concentration of reactant and product is constant at equilibrium state. Such type of reactions are equilibrium reactions. Understand all of you? Right. So if you take the concentration for the both, so look at carefully. So now one of the reaction I am taking, that is, just assume it. So one of the reaction, so just consider a reaction that is so A plus B can be converted into C plus D. It is one of the reaction. So again C plus D can be converted into A plus B. It is a reversible reaction. For this reversible reaction, so first A and B is there. Just it is it is a time axis. There is a concentration axis. So when before going to time, nothing but when time t equals to 0, concentration of A and B are maximum. At time t equals to 0, concentration of A and B are maximum. That concentration, actually that means 100%. That concentration is decreases up to 58 only. Just we are taking this number, it is not exact. So here, so this is decreasing like this with a time. Yes. Then, so even though same like this, so concentration of D, C and D, when time t equals to 0, 0 only, nothing is there. So that will increase with a time like this. So assume at these are at a particular stage, at this stage, assume it. So constant, they are not changed, the concentrations are not changed at this position onwards. So whatever the time is happens, how much time it will be happens, so concentration is constant, so that stage only we are calling equilibrium state. Remember it. Understand now what is the equilibrium. So now, of course, it is understandable. So one more example I will give to you. So just note it in case if you want that. Yes. So here, one of the example to you for the equilibrium state itself. So we are taking a solid iodine I2. Solid iodine it is. So we are present in the closed vessel iodine. So after some time, so this solid I2 can be converted into vapors. So actually iodine I2 vapors are violet color gas it is. So solid I2 can be converted into vapor state, so that violet color increases with the time. Okay, then after at equilibrium, it happens at starting initial stage before going to establish the equilibrium state. Before going to establish the equilibrium state, violet color increases. Understand? Violet color gases increases. But at equilibrium position, intensity of color constant, unchanged, does not change at that position. So why, what happens? Because sir, here solid I2 gas can be converted into vapor gas, then again vapors are converted into solid. So both are constant, the concentrations are constant. So that is why at equilibrium position intensity of color is unchanged. So that we are calling equilibrium state. So now we have to discuss some of the points. What are the characteristics of equilibrium? So then later we have to discuss about the types of equilibrium. So what are the characteristics of equilibrium that we have to discuss? This is the main important for the objective examination, for the JEE and NEET if you have to go means. So which type of questions they will ask based on these what we are discussing now, that I will explain to you people. So these are, which are characteristics of equilibrium. So one by one we'll discuss. So first one, for the characteristics of equilibrium, first one I am telling that. So at equilibrium, both forward and backward reactions continue to take place. Both forward and backward reactions are continuous to take place. That is the main characteristics of equilibrium. It won't stop at equilibrium position, that you have to remember it. So at equilibrium position it won't stop. Then equilibrium state, second characteristic, at equilibrium state at equilibrium state, rate of forward reaction is equals to rate of backward reaction. Rate of forward reaction is equals to rate of backward reaction. And the third one, at equilibrium state, properties such as mass, volume, intensity of color, concentration are constant. So that you have to remember. Yes, at equilibrium state, properties such as mass, volume, intensity of color and concentration, so these all are constant. Next, the fourth one, equilibrium is not a static equilibrium. It is not a static, it is a dynamic equilibrium. It is not a static, it is a dynamic equilibrium. Sir, why it is not a static? What is the meaning of this? Sir, for example, if you take this, just assume it is one of the object. It is one of the object. So this side we are applying a force. Even this side equal force if you apply both sides. So this object it won't change. So both sides. So for example, it is object this side and this side. Both sides if you apply the same force, it won't change from this direction or this direction. But equilibrium position, both forward and backward reactions are continually takes place. So nothing but forward reaction is going on, then backward reaction is going on. It won't stop, continually takes place. So that is why we are calling it as a dynamic equilibrium. It is calling it as dynamic equilibrium. So then one more characteristic property, that is for delta z, when delta z equals to 0, reaction is present in equilibrium, we call. Reaction is present in equilibrium. So one more property also is there, that is, so what are these 5 characteristics? First note it. Then one more characteristic is there. So sixth one, when concentration, pressure, temperature changes takes place. Position of equilibrium also may change. Position of equilibrium also may change. So when the concentration, pressure, temperature changes takes place, position of equilibrium also may change. Then, so one more, in case if you use catalyst in the reaction, if catalyst used in reaction, position of equilibrium does not change. Unaffected. Just so these are the characteristics of equilibrium. So now very few questions we have to discuss about. So up to the what point we are discussing. So first reversible reactions, irreversible reactions. Based on that, some examples we are discussing. How the equilibrium state is established we are discussing. Then, so how does concentration will be decreases and how does concentration will be increases of reactants and products, that also we are discussing. Then later characteristics of equilibrium discussed. Based on that, sir, in the JEE or in the NEET, sir, which type of questions they are asking? So just 2 to 3 questions I will explain to you. So listen. So which type of questions they are asking? So it is a previous question. Which of the following is correct for? Which of the following is correct for? Which of the following is correct for? So N2 plus 3H2 gives rise to 2NH3. So it is the reversible reaction, equilibrium reaction only. They are given the options like this. So graphs only is given. So that is, in the first graph they are mentioned that. So N2, then H2, so all are equal like this. So this is the concentration they are mentioned. Then this is time they are mentioned. Then the second option they are mentioned that. And the second option they are mentioned that. So concentration of H2 is decreasing like this. Concentration of N2 is decreasing like this. Then concentration of NH3 is increasing like this. So the concentration, then time. Third option is given, that is the concentration of NH3 is given, it is NH3. Then they are given H2 and N2 concentrations with the concentration time. So fourth option is given none of these. None of these. So look at. So here H2 they are mentioned, it is N2 they are mentioned, it is NH3 they are mentioned like this. So here in this case, if you observe carefully, so reactants which are N2 and H2 are reactants. So both concentrations are decreasing, then product concentration is increasing. So this is the correct answer for this. Then here, so one thing you have to remember, why it is not correct. So even though N2 they are mentioned here, H2 they are mentioned here, N2 they are mentioned here, then NH3 they are mentioned like this. So but not equal, all the concentrations are not equal. Concentrations are constant but not equal. Rate of reaction is equal, That you have to remember. So when the rate of reaction is given at this place, then it is okay. Both rate of forward and rate of backward reaction is correct. Now they are given the concentration, so that's why concentration and time, at that time you have to take, this is the correct answer. Understand? Yes. Next, one more question I will explain to you. Which of the following is irreversible reaction? Which of the following is irreversible reaction? So they are given the reactions, that is PCl5 can be converted into PCl3 plus Cl2. Then second one is 2SO2 plus O2 gives rise to 2SO3. Then third one is given. So N2 plus 3H2 gives rise to 2NH3. Then fourth one is given. So 2KClO3 gives rise to KCl plus O2. 3KCl plus 3O2 like this. So now I told that all the decomposition reactions are irreversible reactions. Then and between the strong acid and strong base where the reaction takes place, that is also a reversible reaction. Then all precipitated reactions are irreversible reactions. So that are irreversible reactions I told. So here all these are above 3 are gaseous reactions. In case if they kept in the closed vessel, it happens. These all are when it is present in the closed vessel. So maybe reversible reaction takes place. Otherwise irreversible. But here this is the solid, even this is a solid, here it is a gas. It is a decomposition reaction. Actually it is a thermal decomposition reaction. KClO3, one of the product can be converted to two different products. One of the compound can be converted to two different products. So then such type of reactions are decomposition reactions. So decomposition reactions are irreversible reactions I told. So this is such type of questions they will ask. So thank you. We will discuss in the next chapter.